Equilibria. And in this chapter alone, so there's a few elements that you guys need to pay more attention to, especially on pH calculation. You have to know how to calculate pH of strong acid, strong base, weak acid, and also pH of a buffer solution. After that, it's going to be partition coefficient and also solubility product. So these 4 elements is very important. These are the key 4 elements in this chapter. So please pay more attention to it, especially like dealing with questions with long calculation. So please go through the entire notes and go through more questions with calculation. So let's go. Yes! Let's look at your method 1. If you guys want to work backwards for method 1, can. First, concentration of H+. How to concentration of H+ again? It's 10 to the power of negative pH, 10 to the power of negative 13. Okay? So guys, once you have your concentration of H+, second, concentration of OH minus. How to get concentration of OH minus? Kw equals to H plus OH minus, right? Is that right? So OH minus is equals to Kw divided by H plus, which is 1 times 10 to the power negative 14 divided by 10 to the power negative 13. And your answer should be equals to 1. Okay, then same thing. Okay, third step is the same. Just the first and second step is different. Bro, I missed out so much because only like 5 minutes ago I received a WhatsApp message. Oopsie. I try to find an old recording for you guys. Like you watched the last year one. Yeah. I mean, I still have the last year recording. Yeah. It's just to catch up with the first, second page. Okay. So guys, once done, we can move on to the next part because that is considered the first part of Ionic Equilibria. So far doable, right? Okay, very doable. Yeah, because that's the easiest. Okay, let's go. We have some exercise. Let's do some exercise. Okay, before we move on to the next part. Okay, let me see the question first. Okay, this is AS. Let me SS. Why SS? Go faster. Done. This question is AS chapter 7, conjugate base. This one is also this is A2 chapter 30, nitrogen containing compound, which we done it on Friday. But you too fast, how? Go. Go. Screenshot. Wow. What are you doing? Oh, playing game, right? Playing game, right? Minecraft. What game you guys play? Minecraft, Roblox. No, you guys don't play Roblox. Roblox for the kids, bro. Okay, write an equation, water acting as a base. Okay, this water as a base, this is so AS chapter 17. So guys, you see, you still need your AS knowledge. This entire question is AS. Next part, page 1. If you get this wrong, that means you never focus in my class, bro. We just did this. Okay, guys, this one, AS chapter 7. Okay, and this page. No, this one, no. This one is just critical question. Critical thinking question. Yeah. Good. This question is good. The remaining question, please try to recall your AS. Go. I go washroom. When I'm back, I will start discussion. And I'll walk around to check all your answers. Hopefully, you guys will prepare your AS. Right, hold on. Good job. All right, guys, let's go. Guys, again, what did I mention about acid? Acid forms conjugate base, right? So acid forms conjugate base, right? And base form conjugate acid, right? Guys, I want another acid. So guys, what is acid again? Please tell me. Acid is a proton donor, right? So guys, can I write it as NO2 minus and HNO2? Yes or no? No. Why, guys? You see from here, they are accepting a proton. So this is your acid. Am I right? HNO2 is your acid. NO2 minus is the conjugate. Remember, acid is a proton donor. Okay, remember guys, acid, proton donor, base, proton acceptor, pH is a measurement of H plus. Okay, that's the very, very fundamental things that you just, these three, right? Okay, please remember this. Okay, guys, next, what did I mention about base? Base is a proton acceptor, right? Am I right? Then you guys will be wondering, hey, how this thingy accept a proton? Go. Like guys, if I put a proton here, can anyone tell me where the H plus will go? To which part? To nitrogen. Why? That's a lone pair, right? So guys, where is your answer for lone pair? Okay, so again, very simple, right? This H plus go to the lone pair, right? Am I right? So I can mention that your lone pair on nitrogen, okay, accepts a H plus, done. Yes, correct. Okay, so you have to tell me where. Lone pair. Lone pair is the one that accepting a H plus, right? Remember, our base is a proton acceptor. Done. Cool. Next. So guys, this question, some of you guys not getting it right. Very simple. Show water. I write water, H2O liquid. Then react with a CH3COOH equals, correct. Then I do not know what to do. Die. Then guys, highlight the word water acts as a base again. What is a base again? Base is a proton acceptor, which means the H2O will accept a proton, right? Which means this hydrogen will just go to H2O, right? So H2O turns into a H3O plus and CH3COO minus. Is that right? Okay, that's it. That is a dissociation equation for ethanoic acid. Okay, so this is still AS, yeah. Okay, the only A2 part is here. That is the only A2 part, because you need to know how to draw this. But the fundamental is still AS. So this entire question is 30% AS, 30% A2. Okay, guys, next. All right, guys, you see, what did I mention about KW? Should you remember what did I mention about KW? KW is a constant, only changes with temperature. Do you see that? That's a graph. Guys, you see, under room condition, where's my room condition? Do you see under room condition? Is 1 times 10 to the power of negative 14. Am I right? Clear? All right, guys, KW, H plus, OH minus. Is that right? Okay, 3 mark here. Okay, now, kid, I have a question. Is this endothermic or exothermic? Go. It's AS. Wow, so fast. Wow, so fast. Thank you very much. Whoever get endo is correct. Okay, yes, the answer is endothermic, but let me explain why. All right, kid, let's go. Okay, as your temperature increases, right? Guys, what happened to your K value? K value also increases, is that right? All right, so guys, recall AS. When your K is higher, which means it favors forward or favors backward? Forward, right? Am I right? So which means when temperature increases, favors forward. Guys, recall AS again. Increased temperature favors endothermic, right? Which means forward endo. Done. It's just AS. Guys, remember, yeah, your KW is just like any other K. K is high, forward reaction. K is low, backward reaction. Okay, and K is a constant, only changes when temperature changes. It's just like AS, your KC, KP. Now we have KW. Okay, so guys, the same thing. Okay, I'm just gonna put entire thing into words here. So first, I can say that as temperature increases, KW increases, correct? Okay, then what else? When KW increases, favors forward reaction, right? Okay, next. As temperature increases, favors endothermic, right? Then conclusion, forward reaction equals endothermic done. All right, in exam, you just put in words, too lazy. Okay. Okay, last question. Let's go. Okay, an aqueous solution has pH 7 at 30 degrees. Okay, use your information to explain why your solution can be considered an alkaline. Okay, so they say, right, explain why this solution can be considered as alkaline at 30 degrees. Okay, so guys, again, remember, right? Okay, before we move on further, guys, your pH 7, right, is neutral, right? It's only valid at room temperature. Understand? So which means, yeah, if you increase temperature or decrease temperature, pH 7 is no longer neutral. Understand? pH equals to 7 is neutral at room temperature only. Why? Because when you increase the temperature, your K value also changes, right? All right. Okay, guys, now they say why pH 7, 30 degree, it's considered alkaline. Very simple, guys. You can explain with calculation. Okay, you can explain with calculation. Okay, so if you don't want to explain with calculation, right, no problem. Okay, so guys, now let's look at your pH equals 7 at 30 degrees. So guys, please tell me what is your Kw value at 30 degrees? Read the graph. So Kw is 1.55, right? 1.5. Kw is 1.5. I think it's slightly above, right? 246. Oh, yeah, 1.5. Sorry, my bad. Because one box is 2, right? 2, 4, 6, 8 times, right? 1.5, correct. So guys, I know that, right? pH equals to, don't play with me. 1.5 times 10 to the power of negative 14 at 30 degrees. Okay, so at 30 degrees, pH equals to 1, Kw equals to 1.5 times 10 to the power of negative 14. Okay, the next thing is, guys, now you have to recall your method 1. Yeah, I want you guys to recall your method 1. Okay, so guys, can you calculate for me, right? What is the concentration of H plus? Okay, at 30 degrees. Using your Kw value, please calculate. Okay, I want you guys to calculate what is the concentration of H plus at 30 degrees. One times 10 to the power of 7, right? Okay. So again, your concentration of H plus is gonna be square root of 1.5 times 10 to the power of negative 14, right? It's not 1, it's gonna be slightly higher, right? How much is it? 1.22, right? Negative 7, is that right? Okay, so is your answer 1.22 times 10 to the power of negative 7? Okay, guys, I know that, right? Okay, when your Kw equals to, at 30 degrees, okay, so this is the neutral. This, what you're calculating here, this is the neutral, you know. Understand? Which means, right, neutral should have this amount of H plus. All right, guys, next. Please also calculate for me at pH 7, what is the concentration of H plus? Go. Okay, so concentration of H plus is going to be 10 to the power of negative 7, right? Which is 1 times 10 to the power of -7. Is that right? Correct. All right, guys, which one is lower? This one is lower, right? Correct. So, guys, what did I mention about alkaline? So, let's look at alkaline. Okay, let's look at acid first. Acid, right, is when you have a lot of H+. Alkaline is when you have very little H+. Remember, yeah? So, guys, okay, so right now, right, pH is a measurement of H+. Again, let's look at some calculations we have. Okay, so let me explain a little bit, yeah? Guys, you see, where is my, this question. Let's look at the pH now. 7.4, right? This is alkaline, correct? Okay, let's look at the value of H+. The value of H+ is very small. Remember, alkaline solution, you will still have H+. It's just that the H+ is very small. Okay, and the H+ is lower than 1 times 10 to the power -7. So, guys, now can you see that the H+ here is lower than the neutral, which means this solution is alkaline, right? So, guys, I can say that. Okay, so this is my conclusion, yeah. I can say that H+ concentration at 30 degree, okay, for pH 7 is less than 1.22 times 10 to the power of -7. All right. Okay, which means the OH minus concentration is greater than H+, solution is alkaline. Done. One and a half hour, we did 5 pages. Yes. 3 pages of note, basically. 2 questions. Yeah. So it will get slower and slower. All good. All right, guys, give you another 1 minute. We are moving on to page 6. All right, guys, now let's look at page 6. We have acid dissociation constant. So, kid, first, let's look at weak acid. Guys, weak acid dissociate partially. Well done. Thank you very much. Okay, dissociate partially in water. Okay, so the general formula for a monoprotic acid is HA. So the balance equation, right, is HA. When they dissociate partially, H+ is always formed and A minus. Okay, a good example, right, guys? Let's look at HCOOH, methanol acid, dissociate to form H+ and a HCOO minus. Okay, the same thing. All right, guys, now, okay, I want you guys to write down your equilibrium constant. Go. Write down your equilibrium constant. Again, apply your AS knowledge. So is it concentration of H+, concentration of A minus over concentration of HA? Correct. And guys, this entire expression has a name given. We call it as Ka. Okay, so this entire thingy, right, we call it as a Ka, which also known as acid dissociation constant. Okay, so guys, now let me ask you guys a question. Think first before you answer. Okay, guys, the strength of any weak acid, right, depends on Ka. which means the higher the Ka, the stronger or weaker the acid. Stronger. Why? Yes, good one. The higher the Ka, the stronger the acid. Well done. Good job. Okay, guys, now I want you guys to tell me why. What's the reason? Because when K is high, recall AS, more forward, right? Correct. Which means dissociate more, right? Which means H plus form is higher, right? Understand? Try to understand, don't memorize. Memorize does not work, yeah, in A2. There's no memorizing. Okay, try to understand all this KW, Ka, everything. Go and understand it one more time. When Ka is high, which means there's more forward reaction. Is that right? Which means all the weak acid dissociate to form H plus, which means H plus is high, which means it's more acidic. Okay. So guys, as your Ka value, right? Ka value is actually very, very lower. Ka value is super low. So we can use pKa to represent, to make it higher. So pKa is the same thing as pH, just that we are changing H plus into log base 10 Ka. This expression you also need to accept. You also need to memorize. Okay, good. All right, guys, now, okay, let's look at the first knowledge that you guys need to know. Yeah. Okay, so after this lesson, right, if I give you a Ka value, okay, you should be able to tell me is the acid strong or acid is weak. Okay, guys, let's go. If the Ka is high, okay, please tell me, what's the story follows? Favor where? Favors forward reaction, right? Correct. Am I right? Which means would dissociate more, right? Which means it's a stronger acid, right? Or the concentration of H plus is higher than lower pH, right? Stronger acid, yeah. Understand? Okay, guys, I think Ka is okay. Okay, understand Ka? Next, we have pKa, die. Sometimes they give you pKa. Oh, then what is pKa? You see, right? You have to know what is pKa also. So, guys, pKa, right, is just negative log base 10 Ka. Wow, very hard to visualize this, right? Like, very hard to visualize high or low. We cannot tell. There's no relationship. So, to give you guys a relationship, right, you just have to read, yeah? Okay, your pKa, when you see a pKa, right, in your mind, switch it to a pH. Okay, when you see a pKa, right, just switch it to a pH because it's the same calculation, negative log base 10. So guys, if you see it as a pH, then it's very simple. When your pKa is high, which means you read it as a high pH, right? Which means you have a weak acid, right? Easy, right? Okay, try to understand this conversion, yeah. Okay, so later we're gonna do some maths. Now I want you guys to eyeball it by just looking at a pKa and Ka, that you guys can compare the strength already. Okay, because sometimes they'll ask you, hey, which one is a stronger acid? Then immediately you need to down. Okay, so guys, very simple. Let me ask you guys a question, yeah. Let's go. Guys, when my Ka is high, what happened to my pKa? Low. Good job. Opposite one, okay, or when my pKa is low, then Ka is high, right? Okay. What am I writing? Okay, guys, when my pKa is high, Ka is lower, acid is weak or strong? Weak. Easy, right? Right, guys, one more time. If my pKa is low, acid is strong. Ka is high. Okay, please one more time. When my Ka is low, acid is weak. pKa is thank you very much. Can I understand the relationship? So guys, in your mind, you know how to determine Ka, pKa, acid strength. Can. Okay, guys, do this question. Which acid is stronger? You either convert to pKa to compare or convert to Ka to compare. Up to you. Okay, but you guys gonna tell me which acid is stronger before I let you go. So guys, which acid is stronger, A or B? B, most of you guys able to get B, okay, so good. Okay, before B, okay, so before I let you guys go, let me show you the reason why. So you can either convert a pKa into Ka, or you can convert your Ka into pKa. I think converting Ka into pKa is easier lah. So guys, just convert your Ka into pKa, negative log base 10, 1 times 10 to the power negative 15. How much is it, 15. Okay, so guys, do you see that acid A pKa is very high? Acid B, do you see that your pKa is lower? Correct. So guys, remember, pKa, read it as a pH, which means this is a lower pH, which means acid stronger, right? Done. Okay, easy. Okay, good. Or you can convert into Ka, it's the same thing applies. Okay, good. So that's it. So before I let you guys go, to summarize, we did few equation. What is Kw again? H plus, OH minus, and this is a constant value at room temperature is 1 times 10 to the power of negative 14, right? Okay, remember, because maximum pH is 14. That's it. Okay, next, to calculate pH is always negative log base 10 concentration of H plus. All right. Next, we have Ka. K is equals to a H plus A minus HA. Well done. Next, Ka is high, pKa is low, acid is strong. That's it. Yeah, we use 1.5 hours to learn do, re, mi, fa. Okay, good. So that's all for the class today. I'll see you guys next week. I'm moving very, very slow because this is the hardest chapter. Yeah. So that's all for the class today, guys. Please like and subscribe. So someone can take it. Please like and subscribe.